Okay, this video is going to be about IOA 1D. Show and explain subtraction of rational numbers as adding the additive inverse, i.e. p minus q equals p plus negative q, and show that the distance between two rational numbers on the number line is the absolute value of their difference, and apply this principle in contextual situations. So let's take a look at what these example problems would look like. First up, we have problem number 3 here, which says how much warmer is 82 degrees Fahrenheit than 40 degrees Fahrenheit? So if we think about a number line here where we've got all of these temperatures, we've got 82 degrees Fahrenheit, which is just past 80 at right about here. And then we have 40 degrees Fahrenheit, which is right about there. So we can see that this would be about their distance from one to the other. In order to calculate that distance, we're going to need to find their difference. Remember, that's what the IOA says, is that the show that the distance between two rational numbers on the number line is the absolute value of their difference. So if we look at the difference between these two, we're going to take 82 minus 40 and find the absolute value of that. Because remember that word difference, the word difference, if you see the word difference in math class, typically that's going to indicate to you that that means we are doing subtraction. So we're going to find the absolute value, and I'm going to use these vertical bars here to indicate absolute value of 82 minus 40. So let me put that in my calculator. The absolute value button on Desmo's calculator is right here. So I'm going to press that button and do 82 minus 40. And we can see that the answer is 42, and that is going to be the difference, the absolute value of their difference, and it is going to be the distance between those two. So that means how much warmer is 82 degrees than 40 degrees? 42 degrees Fahrenheit. Now the second question, how much warmer is 82 degrees Fahrenheit than negative 40? All right, well, this is going to be slightly different, but the same process. So we have, again, we're starting at 82 degrees, but this time we're looking at negative 40. So negative 40 is all the way down here. That's going to be the distance between those two. You can see that's much bigger than 42. So now I'm going to calculate absolute value of the difference between those two, just like we did before, except be careful to indicate that it's negative 40. So we have absolute value of 82 minus negative 40, like that. All right, let's put that in the calculator. So absolute value of 82 minus negative 40, and there we have it, 122. So how much warmer is 82 degrees Fahrenheit than negative 40 degrees Fahrenheit? The answer is 122 degrees Fahrenheit. Okay, let's take a look at number 2. Rewrite each expression below as an addition expression, then solve each expression. Oh, rewrite it as addition, so I guess I can just change these all to addition, huh? Done. Huh, if only. Unfortunately, we cannot just change a math problem because we feel like it. Instead, we must change this to addition by writing an equivalent expression. I'm going to write this phrase up here because this is a nice key vocabulary term. Equivalent expressions. And this will come up again when we start talking about equations and algebraic expressions. But we're going to write an equivalent expression to each of these statements here. And these subtraction statements can be rewritten as addition statements by simply writing it as their equivalent expression. So first we have A. I'll do A in this blue color here. So A, A can be rewritten as -5 plus parentheses 3 1/2. Taking away a -3 1/2 is going to be equivalent to adding a +3 1/2. If we take away a negative value, we remove a negative value, then overall the change is going to be positive. So -5 plus 3 1/2 is going to be our equivalent expression. So let's take -5 and add 3 1/2. And really, we don't need these parentheses here, but I'm going to keep it for continuity. And we have -1.5. I don't really like that. I had a fraction in my answer or in my question, so I really want a fraction in my answer. So that's going to give me -3/2. We know we can also rewrite that improper fraction as -1 1/2. So either of those would be acceptable. Okay, second, let's do part B. Go for a different color here for part B. Part B says 7 minus -2 1/4. And again, we're just going to rewrite that as the equivalent expression minus negative, nope, we want it as an addition expression. So I know if I'm taking away a negative value, that's going to be equivalent to adding a positive value. So 7 plus 2 1/4 is going to be my equivalent expression. And that is what I'm going to put into my calculator. So we're going to take 7 plus 2 1/4, just like that. And it gives me 9.25, 9 and 25 hundredths. But again, I don't really like that this gives me a decimal, and I had fractions to begin with. So I'm going to change that back to the improper fraction form, 37 divided by 4. And again, we could rewrite this as the mixed number if we would like, but the improper fraction is just fine there. If you're wondering, this is going to be equal to 9 and 1/4. And maybe you use commutative property there to rewrite this. 7 plus 2 is 9, plus 1/4 would give you 9 and 1/4. You could also do it that way. Finally, last one here, we have C. Now, part C is a little bit different. What does this say? This says -8 minus +4 3/4. There's only one negative symbol here, only this subtraction to indicate 1 here. So the equivalent expression to this is going to be adding -4 3/4. So the equivalent expression is going to be -8 plus -4 3/4. Okay, we can put that in our calculator, and if you would like to, you can put parentheses around that to make sure we keep the negative sign with that 4 3/4. So -8 plus parentheses -4 3/4. And so I get an answer of -51 divided by 4, or -51/4. And again, if you want to kind of think of this with the commutative property, you could rewrite this as -8 plus -4 plus -3/4, and then add together your -8 and your -4. Sorry, I almost went off the page there. That would be -12. And then we have this -3/4, so this would be -12 and 3/4 if we were to write this as a mixed number. So there you have it. There is rewriting each expression below as an addition expression and solving the expression. Those are our answers there. And so we have completed IOA 1D. Thank you for watching.